Separable differential equations. Whoops, that's the practice schedule for Alliance Soccer right there. So I'm coaching the one U9 boy team and one U6 boy team.
So you actually do know how soccer works.
I know how soccer works. Like you try to get the kids going the right direction
but you don't keep track
and to
score.
kick it in the goal. That's the 6-year-old version of soccer coaching.
My dad was a coach for like 5
All right,
years.
solving separable differential equations. We'll assume you know what an equation is. A differential equation is an equation with a derivative in it. Like built into the equation is a derivative. It's part of the equation. That's the differential part. Separable is the only type that we'll solve, and so it's hard to define separable until we get a little bit into this. But it's the only type that we'll deal with. I think it's also the only type for Calc BC as well. Solution to any differential equation is a function. The solution to dy dx equals f prime. Like we could almost do this one sort of symbolically, even though there's nothing like detail-wise there. Because if you integrate both sides, the integral of the left side, the antiderivative of the derivative would be y, and the antiderivative of the derivative of f would be f. But don't forget the plus c. We still have the plus c to worry about.
You said that's where separable comes in.
And why it's called the general solution is because of that plus c. So even if we have some y's and x's and we get a function, the plus c on there just means we don't know exactly what this is, right? Like it's x squared, but is it x squared plus 7 or x squared minus 5? Like we don't know yet. It's a general solution. In most questions, you're given a point,
The jumping off point.
an initial condition. You've kind of used these. Even on the test, we didn't call them initial conditions. That the point goes through. That sort of anchors or lets you know what C is and so where your graph is.
Like x of 0 equals 4.
So if you know C, then you have the particular solution. And so it's a little bit like integrating with limits and without limits, right? With limits, you have a definite integral and a definite solution, a definite answer. Without limits, you got a plus C. Kind of like that here. You start out with a plus C, but we'll give you some information to get you to the particular solution.
Okay.
Just a little aside here, there's an entire college course devoted to solving various types of differential equations. It's called differential equations. So you can spend a whole semester taking differential equations.
One semester?
And then it's a 1-semester course. After that, if you hang around math long enough, you'll take partial differential equations.
That sounds yucky.
It is. So, depending on if you're engineering, you'll do Cal 1, Cal 2, Cal 3. Maybe you get credit for Cal 1 through this calculus course.
If you took BC, you could get.
After that, you take DifEq, and then these are the common abbreviations. PDE, partial differential equations. And that probably completes your math requirements for a engineering degree.
Hopefully.
In this course, we're only going to solve separable differential equations because beyond that is kind of crazy.
Fourth year college.
Not even partial, like we're only going to solve part of differential equations, not the hard ones in this course, the easy ones in that course.
Okay.
A separable differential equation can be written in the form f of y dy equals g of x dx. meaning you've separated the x's and y's. You've separated the x's and y's. If you can't separate the x's and y's, you're not doing an equation in this class, because we're not going to do those. So if you can't figure out how to separate them, then either I made a mistake writing the problem, or your algebra skills need some work to get the x's and y's separate from each other. So a function of y, meaning basically just y stuff. So all the stuff with y goes on one side. And it could be a constant over there. And then a function of x on the other. All the x stuff on the other side. You've done that before in Algebra 1. Like, get all the y's on the right and all the x's on the left. It's a little bit like that. Get all the y stuff on one side, all the x stuff on the other side. Once everything is separated, then you can integrate both sides. The mantra for solving separable DifEqs, differential equations, and maybe this sounds silly, but it's rather important. Separate, then integrate. Because you can't integrate until you've separated. I mean, you can try, and that's the mistake people make, is they just jump in and try to integrate things, and it doesn't work. So separate, get the x's and y's separate, and then do the integration.
You can even use the 2
Let's do number 1. Solve this differential equation, given that the point 0, -4 is on the graph. All right, so that 0, -4, let's kind of back up and see what we've got. 0, -4, that's what we call the initial condition. That will help us, we'll use that to solve for C. And that will take us from the general solution to the particular solution. So we use that sort of at the end.
Okay.
At the beginning, all right, I need to separate the x stuff and the y stuff. So I need to get all my x stuff on one side, all my y stuff on the other side, including the dy dx. So I think I want to subtract x squared from both sides. And then multiply both sides by dx to get it to the other side. So 3y dy. By the way, you probably want to write kind of small, because we're going to do 2 columns here to get all this in. 3y dy equals -x squared dx. Okay, so I've separated all. Everything with the y stuff is on one side. Everything with x stuff is on the other side. I don't know that it's worthy of an exclamation point to celebrate, but that's the first step. I mean, we're a long way from done, but you've got to get the two separated first.
Before you can start anything.
Now we can integrate. Let's integrate both sides. Power rule. Trey, you get 2 chances to do the power rule here. I should call on people. In fact, I will call on people. Trey was grumbling about the power rule. So if I can find it quickly, I'll just accidentally, on purpose, pull Trey out for one of these. I can't find Trey, and
He's in the draw.
Preston's messing with people, so we'll go with
Yeah.
he's leveling false accusations, best I can tell.
Kind of sus you can't find
Is it sus
Trace.
that Trace isn't in the bucket anymore?
Are you accusing him of?
I did not take it out.
Might have taken it out.
I saw him taking that.
Okay, I'll be completely honest. No, listen. I was gone the day we made him at the very beginning of the year. You never got
Wow, you never.
never got going.
I wasn't here the day we made him either, and he made me make one.
I
He
think
didn't
Trey.
make me- he didn't
I think
make me
Trey
make
should
one.
answer every single one from today.
Why?
I think you should change.
He's
my
writing one for me,
signature
Trey.
to
At least make it cool. Make it cool.
Make it cool.
Like draw something on it.
REESE.
Yes.
No,
All right, Trey's going to be up next after Preston and Brandon go for us here. So Preston, the antiderivative of 3y with respect to y.
3y squared over 2.
Yes.
Good job.
I'm going to write that a little bit different than how you said it, but 3y squared over 3 halves y squared. 3y squared over 2, same thing. Brandon, how about the antiderivative of negative x squared? Good. Negative x cubed over 3.
Plus C.
Plus c. Now, you can put the plus c on either side.
You
But-
put it on both.
You don't need to put it on both because the plus c could be anything, so there's no point in putting it on both. It's not wrong to put it on both, but put it on one, and almost always we put it on the x side. Mainly because if we can solve for y, we'll solve for y, and so it's one less step in solving for y if it's already on the x side of things. Okay, let's see. Let's start to solve for y. So let's multiply by 2/3. So y squared equals negative 2/9 x cubed plus, this is where people are gonna freak out. Because right now, c can be anything.
Yeah.
So 2/3 times anything. I don't know what c is, but 2/3 of I don't know yet means I still don't know yet. So I don't need to call it 2/3 c. I'm just going to call it c. Now I guess I might need to be a little bit careful because those c's are not the same.
Could you put like C sub 1, C sub
And so some people, to be careful about that, call one of them C1 or C2 or C without anything and call the previous one C1. Those aren't the same number, but I don't know what the number is yet, so
We'll
I don't-
find out.
I don't need the 2/3 on there.
Y equals the square root of it.
Yeah, but if I square root it, then I got to think about the plus or minus.
Oh, yeah. Never mind.
So I think I'm just going to leave it as that. I'm not going to put a square root on there because then I have to do the plus or minus thing. So this is our general solution. So generally we know what the graph looks like. I mean, I don't know what that looks like. But there's a plus c in there that we don't really know yet. So now let's use our initial condition. So 0 goes in for x, negative 4 goes in for y, and we'll solve for c. So negative 4 squared equals negative 2/9 0 cubed plus c. Kind of convenient when they give us one that works out like that. So c equals 16.
That C equals 16.
Yes, the c that we're dealing with is 16. That other c, I don't know, but
Multiplied by
that's
3 halves.
don't know. So now I can get my particular solution. Now that I know c, y squared equals 2/9 x cubed plus 16.
Now you can square root or
Okay, so now we can square root. Yes, now we can square root. And we put the square root, we get the plus or minus, which kind of is annoying because, I don't know, is it really particular if I got a plus or minus on there? You need to figure out which one it is.
Okay.
Particular solution, question mark. because there's only one particular solution.
Plug in X and see which one gives you -4.
That's exactly what we'll do. We'll plug in, sort of go back to where we started, 0, -4, not where we started, but back to our initial condition, and see which one works. It's not hard to figure this one out, but I only want one solution, so I've got to figure out if I want the negative or the positive. I want the negative because my answer is going to be -4.
Yeah.
So if I plug in 0,
and you want the negative.
I get square root of 16, which is 4.
And you want the negative.
But it said -4, so I'm going to pick the negative for this one. So y equals negative square root -2/9 x cubed plus 16. So all of these problems, all is a strong word, most of these problems have algebra to start with. That's the separation part. Algebra, separate, then integrate. Another way to say that is algebra, then calculus. And then use the initial condition. So they're complicated. They all take multiple steps because the algebra might be complicated, the integration might be complicated, and there's usually there's always two integrations. So maybe one of them's hard, one of them's easy. Maybe they're both straightforward. And then you got to plug in your initial condition. So Trey, back to your question earlier of like, why are we doing this for 3 days? Why is it only one worksheet? Because each problem takes a while.
So that's the answer.
So that is the answer. By the way, if we wanted to check that answer,
Plug it in.
you just plug it into the original. X squared plus 3 times y, so here's y. Plug all that in for y. You'd also have to take the derivative of this to plug that in for dy dx.
I assume you get
So
0.
it would take almost as long to check it as it did to work it, so we're not going to check it, but you could if you wanted to. Okay, now for the second part of the notes page.
I think you just take the first page and you turn it over.
Yes, it's out of order. The first page is slope fields, but we're not doing that yet. The back of the first page is day 2, or part 2, I should say, of solving differential equations. One solution, and we can do this if you would like. I can pass the stapler around. You can rip off the first page of the slope, flip it around, and then staple them all back together.
Yeah, let's do it.
So, around comes the stapler.
I feel like I don't need a sticker because I always answer Ty's questions.
So what are we doing?
Fair. So I pass around the stapler because you can take this off, turn it like that, and now it's the second page. There you go. And what was weird was my copies were messed up, Miss Murray's copies were messed up, but they were messed up in different ways. So somebody was confused down there. Let's hold off on number 2. Something different happens on number 2. So we're going to do number 2 on Monday.
Oh, okay.
All right, we got 3 days to get through this, so we got plenty of time. So let's see if we can get 3 and 4. Number 3. Find the particular solution that passes through the point pi over 3, comma 2. So job 1 is to get all the x stuff on one side, all the y stuff on the other side. Why don't you do that right now?
Y squared equals positive cosine x, and then I added the c to that side.
Y squared equals cosine, because yes, the derivative of cosine is negative sine. So that's right. And then plus c on either side, but you may as well put it on the x side.
You need to call on him like randomly though. Like he was ready. He doesn't
Because
know.
I did what he told us to do.
He was ready, but like you have to pull it out randomly.
I'm not ready. I was just.
A bunch of people absent today. So there's differences of opinion here. Like if you can square root now and then find C, or you can find C as it is now. I think I'd rather find it now, and then we'll worry about the plus or minus later.
That's what I did.
But that's how I'm usually going to do it. Some people will get the plus or minus and then figure out which one they want to use. So let's use the point. Pi over 3, 2. So 2 goes in for y. Pi over 3 goes in for x. And we're solving for c. So 4 equals cosine of pi over 3. So steep angle, x coordinate, 1/2.
Bless you.
Thank you. So C equals
7/2.
7/2, 3.5, 3.5, however you want to say it. 7/2 is probably the,
Most common.
yeah, 3.5 would be fine though.
They wouldn't count it.
So y squared, okay, remember this was our general solution after we integrate. Now we know 7/2. I guess we're not going to know our particular yet because we're going to have that plus or minus thing on there. Equals cosine x plus 7/2. Square root both sides, but don't forget the plus or minus. So once again, you got to plug this in and see what works. But not really, because if the y value is positive, so I need to take the plus one. It's not really that big a deal. I mean, you can plug it in and see what works, but eventually, if you want 2 for your answer, you're going to need the positive one. And once again, if you were really committed to making sure you absolutely got that right,
You could check it.
you could check it. You'd take its derivative, that would be the left-hand side of your equation. And then the right-hand side of your equation would be sine of x over that, and see if you got the same thing. Number 4. E to the stuff. Uh-oh. What do you want to do first on number 4?
Separate.
And how do you want to separate? What should we do to
I'll
separate?
put y's on the left and x's on the right.
Okay. So,
I mean, I solved it like left to right as it is right now, and then I just swapped around the sides because it made me feel better to have y equals x.
so I would move the e to the x over. They're both negative, so you can cancel those
Yeah,
out
just
if you
ignore
like.
that.
So e to the y dy equals e to the x dx. Now they're separated.
Never gonna take the other one.
Separate, then integrate. Well, this is... Maggie, how about the antiderivative of e to the y? Good, that's just e to the y. Which means Belle kind of got the easy end of that because hers is the same integration with x's. So the antiderivative of e to the x is e to the x. Well, there's one thing that
I thought they had to go over there.
plus c. You need a plus c on one of those sides. And this is another place where you could solve for y
Let's solve for y.
first and then find c. Or you can be like, let's find c right now and then solve for y.
Let's find c.
Let's find c.
Yeah.
And hope that,
That way it's same process across.
yeah. So at 1, 1, e to the 1 equals e to the 1 plus c. Well, even if you're not super familiar with e, I bet you can figure out what c is.
Or 0.
It's got to be 0. So c equals 0. So e to the y equals e to the x.
Natural log maybe?
You could natural log both sides, which would be fine. I think I'd rather you could just look and see if you got e to something equals e to something, then y equals x. So the technical way and the way we'll do on Monday is take the natural log of both sides.
Okay.
So it's not wrong, and that is what we'll have to do on Monday. But on this one, if you don't see that or you don't do that, and you can just say, look, it's got to be y equals x. You're right, it's y equals x.
Are we going to do number 5? Or is that on Monday?
We are going to do 2 and 5 on Monday. So today's assignment is worksheet 1. I'll give you the
Blah, blah, blah.
questions blah through blah, 1 through 4. I'm going to do 17, and then you'll do 18.
18.
So today 1 through 4, 17 and 18.
Are you going to record 17 as you do it?
Yeah. So let's look at 17. 17 and 18, pretty similar questions. They both ask, is this thing a solution to the given differential equation? So this is, 17 and 18 are checking your work. Does this one work? So 17, y with the 4 like that, that's a fourth derivative. So, it gets a little bit silly to put like 4 little hash marks there. It's fine for the first or the second, but starting in the third,
You start getting it.
we put it in parentheses. So it's not y to the fourth, it's the fourth derivative of y.
Because that's why it's in parentheses.
And it being in parentheses is what tells us that it's the derivative, not the power. Okay, so in order to plug into here, I've got y, so that part's easy. There's y, that'll go in there. But I need the fourth derivative. So there's no way to get the fourth derivative directly. You've got to find the first, and then the second, and then the third, and then the fourth. I mean, maybe some pattern will emerge, but generally speaking, you can't jump straight to the fourth derivative. So e to the negative 2x times negative 2 for the first derivative. I think a pattern will emerge. But Isaiah, what's the second derivative? So the derivative of e to something is e to the something, but don't forget the chain rule. Trey answering everybody's questions again back there.
No, don't look at it.
4 e to the negative 2x. Alex, how about the third derivative?
Negative 6 e to the negative 2.
Ooh, that's a common mistake. 4 times negative 2?
Oh,
It's okay.
negative 8.
There you go. Negative 8 e to the negative 2x. And Landon, our fourth derivative.
16 e to the 2x.
16 e to the negative 2x. So there is some sort of pattern developing here with the derivative, but no worries about that. All right, so y to the fourth is 16 e to the negative 2x minus 16 times e to the negative 2x equals 0. And the question is just yes or no. So is this true?
Yes.
Yeah, 16 e to the negative 2x minus 16 e to the negative 2x. Yeah, that's 0. So the answer is yes. It is. So for number 18, pretty similar. You've already got y. Well, this one's got trig in it, so you'll plug that in for y. but you'll need a second derivative to plug into y double prime, and then see if all the algebra works out or not. All right, so pretty straightforward today. Separate, integrate, and then find C. There needs to be another word that rhymes with separate and integrate that means find C. That's your bonus assignment.
Oh, really?
Separate, integrate, then calibrate. So it was this generic solution, and we're going to calibrate it in. I don't know.
I don't think
That doesn't work.
doesn't flow. Because it's separate.
Try number 1 through
Integrate.
4, 17 through 18.
Fluctuate.
Fluctuate.